Hello everyone, and welcome. This video ahi gravitation chapter ipaddu hitan. Video mas hachana chu rotational motion. Class 11 rotational motion physics hichan chu bolsai hitain. Request them kharom ji ahi class 11 portion pa hi part 1 chan hi na. Part 1 chan chu gravitation chan hi jana chi chan chu i bol diu part 2 bol masang wa hi class 12 portion pa hi bol diu So class 12 portion pa hi bol sai hotin abale class 11 part 2 ayung lut ki diu na. Okay, so we'll do here gravitation. Gravitation long hai na. Video thumne liye hung lut mai the. Okay, so chi video hi laws of Newton's law of gravitation to Kepler's law na. Kepler's law chiten chi bol de hinten. Achom na thai chana kan bol da video hi. So I'll try to make it as short as possible. I want the topic zo si hina pai mo zo se bon ai cover so ke du cha. Okay, then dan Kepler's law kiti chu na her so ke diu jana class 10 azong homza 11 azong omna hechila hi Kepler's law of planetary motion ikha law thuma men na chela hi law thuma choma sapena chu pe ha Kepler's law chu. So all planets move in elliptical orbit with the sun situated at one of the foci of the ellipse. Ellipse kiti in her ta ellipse kiti hi class 11 math geometry akhon sim diu so ellipse kiti chu chi hi atui ta banga khona so zom pa kho. It is not circular path, it is elliptical path. So circle pa ko sine in son pheng leo chun na. You'll get an ellipse, okay? So ellipse hi, so there is something we call focus. Focus nium cho ellipse hi na. Chija cho foci ke cho plural ke cho foci ke cho. So focus nium and then he focus te ni pen khat pen hi ni sana ko yala chun na. So if the sun is situated at one of the focus, then so the ellipse, so this is the path how or where the planet is revolving around the ellipse. Planet ho hai na, so around the sun they are revolving in elliptical orbit. Okay, planet ho orbit pa hai na, japan ellipse shape hai kiti cho first law pa cho. Second law pa cho the line that joins any planet to sweeps equal areas in equal interval of time. Chila example kapi hi velo chun. Example cho chalai para hi chilai chi dinga hai na chi. So let's say time is t1. Okay. So let's take the same time from going here to here. Okay. Suppose let's say T1 is equals to T2. Na. Planet motion pa hai na. Planet motion pa hi PM tele chalayak para hi chalai chi dinga hai na time to hin chalai para chalai dinga hai time hi ke bang. Suppose if we take the same time, okay, suppose T1 and T2 is equals to T1 is equals to T2, then the area sweep, okay, chalai ni sa para hai na, hichi area pa hi area 1 pa hichi pa hi, to hin, chalai area 2 pa hai na jipen so chideni area ke bang de hai ticho. So in one example chalai para chalai ka china hi, suppose say 10 second na, hypothetical, chalai para hi chalai ka china hi, let's say 10 second, okay, khutila time ke bang chalai na, time ke bang sunga chu area ke bang cover di he kiti cho second law pa he khutila chun chila area cover pa he na ji with respect to the sun to chila area cover pa he chiteni area pa he na ke bang di he kiti cho. Okay, that is the second law. And the third law to hi numerical question ho he alhang pi third law base a ke dong ji cho chila hi third law cho pi ham the square of time period of revolution of a planet is proportional to the cube of semi major axis. Butang hi ellipse a he na major axis to minor axis ke ti khanom do chila ellipse pa vela chun chi axis khanom chona chi he chilang hi axis khanom ke ten hi chi pa hi major axis ke ti asa pa he na abana chom pa hi minor axis ke ti to japan he ale semi hong ke ti phala chun half ti na chula na. So here this is the semi major axis, this is the semi minor axis. Okay, na japan hi semi minor ke ti abana jipen hi semi major. Okay, major axis chilaya semi major axis chi distance pa to hin na chi distance pa to hin na time period relation pa cho chi. So this is the relation, t square is proportional to a cube na chi third law is the square of time period chu pe ti na ha one revolution coordinating time kila sa chuna chepen time period ki cho. So the time taken to complete one revolution na bana semi major axis ka sai banga chi cho chi ala chi chu election NCERT ka kuna kala jana third law definition pa na to chu ihon third law hi question apply na dinga chuna. We can also say third law in this way, okay? So what is Kepler's third law? The ratio of the square of time period ki bangna chi of two planets. Suppose planet ni chu around the sun chu ki revolves khutile amani time period pa chuna the square of the ratio ko to divide but the ratio of the square of square of time periods is equal to the cube of the mean distances from the sun. Tichu butang planet kha ki revolve pha le hin na ni sa pa la he distance pa he velo chon ki bang lo chula ki khel khel jing chula. So when you are here, okay, so this is the distance. When you are here, you are closest to the sun. Okay, when you are here, you are farthest from the sun. Na it's like x value pa he. So this value distance from the sun pa he na je pa he khel khel jing cho. So if you take the average of all those things, na je mean to be average ke di chula. I will simple ta sai dinga chuna. The distance of the planet. The assume tau. Heji elliptical path apa hai na assume na chun suppose you have a sun here, the planet is revolving around the sun in a circular path. Okay, radius of the circular path is the mean distance, the average of all this distance. If you take the average na mean path, so okay, so that much you understand, you study, okay. Question I apply the wala chun cho apa hajing so the square of time period of two planets is planet 1 to planet 2 tile. So T1 square by T2 square should be equals to A1 cube by A2 cube. Okay, right? So this relation we are going to use. The question khaleni solve na je. See, the question ka solve hai na. I don't solve many questions here. Okay. Previous question na kala na amasa penai concept hita ka hial masat va bana sa previous question kala khaleni ju I apply dan pa chu ka be so jela he. So here question khaleni bo se solve ajong hi tiha a concept na man tu lo wala chun, so this may not be enough. Okay, HT lo ajong hi lekha book dang khan na follow thai cho. So I will recommend you to keep one book. Okay, example jo ni na ke prepare na hila chun, so ni na ki relate book khan na ki koi dina practice adinga cho chilai ko na question dang zano solve ditine cho. As is I cannot solve all the questions here. Okay, I'm trying to make this as short as possible, but it is enough so to make you understand how to apply the theory na chilai concept hi sim ho hi actual exam question ke dong khona iti apply ding ham che pa choi bola cha jela hi. Okay, Z mains 2024 na chi question hi velo chun alang pia Kepler's no numerical question ki dong ho hi chi ho hi ki bangan kya, so they are the same type of question. Okay, Kepler's third law khona ki dong jing na. So planet takes 200 days. Okay, so time period of planet tiu. So to complete one revolution around the sun, if the distance of the planet from the sun is reduced to 1/4, atila chu r hilachun to chu r by 4 hita cho chi. Then the original how many days to a new time period lo na Japan, so time period final tiu de khat pa hi initial na to the planet khal bosia chi planet khal bosia atila chu 200 days a cover na one revolution adinga chu hichelai chu radius r hi cho ala to hi radius pa hi r pa la chu r by 4 ke sunyaw na to hi radius chu r by 4 hiza a time period ha chu pi hi dem tilachun. So now you can imagine as this as two planets. Okay, planet khat chu it is revolving at 200 days time period. Okay, its radius is r, and I have another planet so which has a radius r by 4 and it is revolving, okay, around the same path na hotel ama second planet path time period tf tiu. Okay, you can also think like that na. So assume two planets, okay, like this. So then I will have T1 and then T2. Okay, so R1 is R, so R2 is R by 4. So Kepler's third law to become T1 square by T2 square is equals to A1 square by A1 cube by A2 cube. Okay, T1 to that 200 square divided by T2 square should be equals to R cube divided by R by 4 the whole cube. Okay, to that ha. So 200 so multiply ho bol hita tin ko ta om dan hin, so T2 square equals to, so R cube divided by 64. Okay, so this cancel out. To T2 square so piyong hiam, so I will have here 200 square divided by 64 na 64 ko ipi square ha 8 square. So take root on both sides. You will have T2 equals 2. So 200 divided by 8. Okay, is that the so 2, 8, 2 are 16, 8, 5 are 40. 25 days. Na time period hapat so. So answer to B. Okay. Habana. Chipen hitu kum Siemens question na. So a satellite orbiting the Earth is 9 times closer to the Earth than the Moon. To moon to satellite khat kila chola na. Ani ni huna hi Earth hi kim vela ke page. So they are revolving around the Earth. So the time period of rotation of the satellite pa time period ke dong na chala hi. Athilachun. So let's say Earth is this one. Okay. Earth to chi hi lachun. But so here I have a satellite. Satellite pa hi kinai zo chuna chi hi. Satellite pa hi moon sanga chu kinai zo entin. Abana chu satellite khela so moon na chala hi. So let's say this is moon. Okay. Athilachun ichana ki gamtha satellite to moon chu pada. So here the satellite is 9 times closer to chola na. Jupi ke say na 9 times closer to. Suppose beta chi chilai pada moon pada Earth distance pa hai na. It's go in home khen leo chun na. So if I say 1 2 3 4 5 6 7 8 9 then at this value, okay. Total cho example cho total cho R lao te na chi. It's pen hi R hi la chun. It's like khat unit khat distance is at ha chi. So this is R by 9 na. So this is the distance of the satellite from the Earth. Okay. Satellite cho R pada R by 9 na gamla na. Kutil chun moon cho R pada 9 R gamla tin cho. Another way of saying is the Earth to satellite distance pa hai na. Chi R hi la chun. So Earth the moon distance pa hi 9 times of R. Okay. So the moon is 9 times away na. From the Earth and then the satellite, okay? Or the satellite is 9 times closer to the Earth, okay? So here, so therefore, Earth to satellite distance by R by 9 hilachun. So moon apara Earth pachu R gamlatina chalai here. Okay, then what else? Time period of the moon chu kipi intin chipen chu TM duty aje. Ale khachu TS tu na time period of satellite question ke dong. So this is ask what is the time period of satellite? Sipa hi TS tu de. Atila chila hi Kepler's third law mamang ki lechun na ibi ha chu. So time period of satellite square divided by time period of moon square equals to so A of S cube divided by A of moon cube. So TS square by T of moon to 27 square equals to so AS chu pi ha. Satellite pachu R by 9 na. Moon pachu R. Okay. So I will have here R by 9 the whole cube. So divided by R cube. Chuchupiha R cube divided by 9 cube into R cube. Okay. So gets cancelled out. Remaining chupiham. So TS square equals to 27 into 27 divided by 9 into 9 into 9 na. Cancel thai cancel le chuna chala hai. So 9 3 are 27. So 3 3 are 9. So 3 9 are 27. 9 9 cancel out. Abona cancel thai ta. So here you have 1 na. So therefore what is this? 1 day tin cho chi. Time period of satellite is 1 day. Third problem. The radius of a Martian orbit around the sun is 4 times. Mars around the sun rotate chula na. So first I have a Martian means Mars. Around the sun is 4 times radius of the orbit of Mercury. Planet ni kipina Mercury to Mars cho chila hai. The Martian year is 687 Earth days. Tichu ehon khana arda ni khari ti pa hoina. Chipa 24 hours iti wala chun. So Mars around the sun one revolution complete nothing acho 687 days ala na into 27 hours 24 hours tina. Alahin chila ke pihe chipen hi piha. So time period of Mars na T1 jute. Mars to 1 hilachun. Question chun Mercury ado na. So here they ask you for Mercury, that means T2 is asked. Okay, so here what else is given? radius of Mars to R1 Newton, Mercury to R2 Tileuhen. Okay, so third law plus na Newton Kepler's third law plus apply lotion. So T1 square divided by T2 square equals to R1 cube divided by R2 cube. A1 cube divided by A2 cube. T1 to Zarham, T1 to 687 square divided by T2 square equals to A1 hui piha. Chalai relation ke pihi piham. So Mars pacho na. So R1 is equals to 4 times of R2. Mars pa orbit radius pacho na. Depends to 4 times of the radius of Mercury ke picho chalai. So how much is this? So R1 cube divided by R2 cube. Okay, it depends to R1 here to 4R2 because it is 4R2 cube divided by R2 cube. Chichu 60 for 4 16 16 into 4 to 64 na. So 64 R2 cube divided by R2 cube. So R2 cancel out. Remaining to PM. So T2 square should be equals to T2 pa hezi lang solve lechun. So 687 square divided by 64 64 to paya 8 square to na. So 8 square. T2 jarang po dadam. So 687 divided by 8. Square root both side la na jala. So jarang hidam 687 by 8. So 8 are 64. 4 in hand 47. 8 5 are 40. 7 in hand 70. 8 are 64. Approximately 85.8 86 na. Approximately 86. So 86 days. Okay, so answer to option A. Depend he NEET 2025 question na medical exam question. Okay, question level how he will na tang he NEET question is na. Chima sangai ho solve for Z mains question na. Apa na Z mains question a level he will ke bang team na. Jadi biam tela Z mains to ni ani ni hi NTA na conduct cho che. Jadi ju alang pia the overall like level hin Z mains question pa hai na. NEET sangai tempa level sounds of it to. Jadi ju NEET exam hi question asu hanum wala na. If they want to make the questions difficult, he just Z mains question also na he cho on la de. Okay, so therefore if you want to score good, okay, physics score hoy na de wala chun Z mains level question to na ke practice ngai tang Z mains question ka tiwang so Z mains question so si ke practice de dinai lo na ji chu Z ya ki dong khalani khu topic khalani khu NEET syllabus a jong lo mai thei chu ai fa chu NEET syllabus khona ve de chu syllabus to ki tu a question ki dong chu na cho chu na ke practice de Okay, so we'll solve one more. The kinetic energy of planet in an elliptical orbit about the sun at a position. Chila figure ke paper hai na. Chila planet khadi tai ki revolve ala chun point A, point B to point C na hi kinetic energy relation na. Chu pe hedem. Wada hi first law pen chuna. So here's the first law. Second law katina. Second law na hi value chun. So to go from here to here, okay. So like distance pa hi value chun. Chipa distance pa to hin iga compare ala chun chilang pa hi left lang pa hi area one lang pa hi south also le na. Ahi wanga chu pya chilai para hi. So to go from here to here and to go from here to here, it takes the same time. Okay. Time ke ba ala chun distance gamla zo cover na ding to speed a gamla ngai chu speed as atam ngai chu na. Okay. So that means chilai para chilai chi ding hi suppose if we say v1 chilai para chilai chi ding hi v2 iti wala chun. So here v1 is greater than v2. Atila to question has a value chun. Here point A na to C na hi value chun. Here see if I want to go from here to here, okay, let's say it takes hypothetically 10 seconds na. Imagine suppose you go from here to here to here, chilai hi 10 seconds ala cho. Okay, 10 seconds ala le to chu chilai para chilai chi na pa hi distance south so chula na. So if this is v1, so this is v2, then we know that v1 is greater than v2. Okay, atila chun the speed will be maximum somewhere here and minimum somewhere here. Okay, maximum at A, minimum at C. Abana so if you think it logically, B chu piha, A to C ki ka alam di chula na chala hi. if you try to imagine, so the motion of the particle here, the speed is the maximum. Okay. He speed he v1 Newton. He achi la chun. Tan chi chan wa speed kal che na che. He su che katina. Speed decreases, so becomes minimum here. Okay, so VB, VC na je la. So must happen to VE. Abala cha VC cho minimum hoi din. Abala cha VC apala cho speed kal che ke na je la. Kal che ke ding din. Abala cho A cho maximum ka phakit na. Ha che ritina cho. Khutile relation cho piha. So VE cho tam pending. Abala cho VB hoi ding. Abala cho VC. Okay, C nya cho long pending na. Chita banga cho vatang kinetic energy cho piha. KE cho half mv square cho la. So half mv square hila chun K to chun V cho they are exactly the same thing na. They are directly proportional. Okay. Until chun KA cho maximum heading abana KB yung heading abana cho KC. Okay, so your answer is option B. Hichan cho Kepler's law question. Bolutin na. To ay bana hin Newton's law of gravitation involved. So see, you think you might have come across this statement. A statement pa here. Every body, so every body in the universe attracts every other body with force which is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. See, I'll try to explain in the story. So the year was 1665. Okay, Newton he Isaac Newton he na Cambridge University anang kai cho. Cambridge anang kai za alehin he phalaya cho khana na plague zia cho na plague zia hi university ke shut down na cho. Ki shut down phalaya ma hi awum na lang na Lincolnshire. Lincolnshire lang ai hong kile ta cho sila hi hong kile enten ji phala hi college a chi thelo phala cho na a study topic pa hi a hin khela na moon hunna. So how the moon rotates around the earth. So in this topic he started doing more studies. Okay, earth like the revolution of the moon around the earth. So based on this topic, okay, he started doing more researches. Research to second law pita. So force equals to m pa ko na. So if there is acceleration, okay, so there must be a force. And if there is a force, then there must be an acceleration. Okay. So any body moving in a circular path, moon bang ako na tilkha cho circular path chiel chun acceleration tete chula na radial to tangential say pao cho. Acceleration tete chun, that means there must be some force which is pulling the moon towards the center. Okay. Ama idea cho na. Let's chu his statement pa na hoi la pan hang por ham tele head bang wa cho apple phung na tawa cho la na. So when he saws the apple falling down, alung themang kelang chopiha lay sit pa na. So the earth is attracting every other bodies around it. Okay, surface la body hojong hena earth in attract a he ti idea pa na. So hung lut alung themana. So that is when he saw the apple falling, he started an idea spark in his mind that the earth attracts every other bodies. Okay, every bodies on the surface, and hichi pa hena hichi laws of attraction pa he earth surface ki hilawa heavenly bodies hochong ajong hena ki apply the he tiso. Ale hichi statement pa he ti hung poram tela Newton in a guess cho. Okay, so Newton guessed that the acceleration so still circular motion perform alachun. Okay, if it is moving in a circular path, there must be an acceleration. Now, it's the acceleration path too. It is inversely proportional to 1 by r square. Okay, so this is what he guessed. That means if there is an acceleration, there must be force. Okay, multiply both sides by mass of any object. So ma is equals to m divided by r square. Okay, abana jo hichi force pa hina according to Newton's third law. Equal and opposite r in tilkhara attract banga chuna hichi thelpa jangchun r hi ale attract it so. So therefore this force chipa hi ma cho piha force chula force of gravitation na hichi force pa hi it also depends on the mass of earth. So mass into m divided by r square. So now to remove this proportionality sign, I have to add one constant. Okay, so therefore I have force is equals to z into m divided by r square. Hichi hi Newton's law Newton's law of gravitation hung kon do dan jana he che pen hi cha chila he z hi biham so z is the gravitational constant, universal gravitational constant. Okay, a value to 6.67 in 10 power minus 11 na. Okay, so we'll solve questions on this one. This video here force question I solve na he che force ki apply dan pa he on abana so question solve na he na force ang kiti phale force vectors or vector hi le chun he che Newton's law pa jong hi vector form as kisi thei cho si he ti akiji dan tabang chala hi class 12 fa electrostatic ka Coulomb's law pa jong khana he che pa jong kisi ri cho si he che lai he thiem wala chun Coulomb's law pa khona anom chom ni cho. Okay, so let's try to write the force in a vector, right? See, suppose I have xy. Sila hi mass nium cho na pa hi mass m1 hintin khat pa hi mass m2. Ale a position pa hi x1, y1 tiu den. Khat pa hi x2, y2 na. Ale bitang xy plane as a point hat hong ma chon hi che points of vector ka si thai chola na. Vector na ji evaluation with respect to the origin vector as ji evaluation ji position vector ki thi cho. So how do I write the position vector here? So for m1 let's say r1. So r1 will be x1 I cap plus y1 z cap na. Chito banga cho r2 cho piham position vector of m2, so which is x2 I cap plus y2 z cap. Okay, chila x1 to x2 hi piham tel with respect to the origin. Okay, r1 r2 ale to hi aman ki ka apa hi piha. So what is this? So this is the distance between them na. Alachun if I want to find out the force on 2 due to 1 ka ate. So force on 2 due to 1. So force acting on 2 due to 1 na. If you imagine yourself as force acting on 2 due to 1, if you imagine yourself as 2, okay, so by how much 1 is pulling you na, force of attraction chala here. So this is the force color. So this one, force on 2 due to 1. The force experienced by 2 due to 1 na chicho piham tele it will be along this side. Okay, as you pull so na attractive force is so if you are m2 you will feel that m1 is pulling you in this direction. Okay, so here I need to find out the distance between them na. So displacement between them chicho piha displacement vector tiu chala na chala he. So here what is this? R huiti ki jide ha r hu vitang displacement vector ka bolta so la khala vector me basic mes para na ver kha wala chun chala chun he de ne vel wala chun, so you just go back and see there. Okay, as you displacement vector ki jidan so ti ki ha simple ta chu if a vector is going from one point to another point, okay, in this direction, then the vector, so this vector na sipahi can be written as so this position vector minus this position vector. Okay, so final minus initial na. Chala pala ke pala chun chi initial heza hi tilang na chi wala chun hi chi final heza na. Chi position vector pa hi chi pa to subtract bol le chun. Okay, so that means so r1 in this case r1 minus r2. So r final minus r initial na. Abang le r2 minus r1 ki jong beta 1 to 2 ju thu below na evanga cho ajidan pa cho. So the final minus the initial. Okay, so how much is this? X1 minus x2 I cap plus y1 minus y2 z cap. Okay, so like this. Atele to so force pa so da iti ki jidem tele z into m1 m2 divided by mod of r the whole square mod r hi pikiti na ha. Example chila hi vele option hi che pa hi r bar so na r bar cho chi hi za khutele mod r so pi di ha. So square root of, so the coefficient of I, okay, so x1 minus x2 the whole square plus coefficient of z, so y1 minus y2 the whole square. Question on apply phala che number hung di na che solve hata hi beto sila him. So this will give you the magnitude, okay, magnitude to distance din cho m1 to m2 ki ka distance pa cha na che him, and the direction is along r cap. R cap cho hilang ha chi r cap. Okay, direction of r means r cap. Unit vector 2, if I have a unit vector a cap, I can write this as a bar divided by mod of a. unit vector property na je he chipa hi apply bolle chun. So z into m1 m2 divided by mod of r square into r bar divided by mod of r bar. Okay, so therefore finally I can write force on 2 due to 1 equals to z into m1 m2 divided by mod of r cube into r bar. So you have to remember this one. Okay, aji chu chala vector form is it tabang wahina class 12 electrostatic azong ku coulombs no pa ko chita bang kisi ki cho chala hem. Okay, so this is how you write in vector Newton's law of gravitation na question solve ke rutin so then that much. Okay, so before we solve actual questions hichi formula apply dan pa hina chipen ga kisil tu ta then question kan ka solve within example. Suppose xy plane ako na batang attraction he is ipia ki ha mon tele earth to moon ki ka attraction pa ki ha mo so na moon is revolving around the earth, so there is an attraction between them. It is noticeable. Okay, ai hibanga su tu hin object 5 kg object khat to 5 kg object khat chu ga koi khom na chun aman ki ka attraction umlam chu ki hello du chu aji jo mass chu nia wal na chala hem. So let's take big mass. Suppose we say 2000 2 into 10 power 4 kg chala yama chala hi. Let's say 1 into 10 power is that la dewa 10 power 5 dewa na 1 into 10 power 6 kg. So there are two objects. Okay, two mass. Let's say let's say 0, 3 ohm na chi chipahi 4, 0 ohm jo chala hi. So then what is the force of attraction? So force on chipahi m1 tutin khatpa ho m2 tute m1 m2 force on m1 due to m2 na question jo. Okay, let's see. Masa pena so bi bole ha r1 r whole nga chola na formula hi r jo chala hi r bar pen hi hol ngai cho ale masa pena so r1 so pi ha position of m1 na position of m1 pa hi chi cho position jo chi na. So how can I write here 4 I cap plus 0 j cap. Okay, so which is simply 4 I cap. And what is r2? R2 to 0 I cap plus 3 j cap. So this is 3 j cap. Chipa hai na position pa cho ale to acho force pa he pi gidonga 1 due to 2 kiti chula na. So between them this is the separation 1 due to 2. So if you are 1, how will you feel when 2 is pulling you? Okay, so that means in this direction towards m2. So force on 1 due to 2. Okay, a direction pa he velocity it is going from 1 to 2. So therefore what will be your r bar? So r bar will be r final minus r initial. Okay, chalai r final he pi ham he telang la chi wala chun chi final na. That means your r2. So r2 minus r1. R2 who is at ham? So 3 j cap minus 4 I cap. Okay, or simply you can write r is equals to minus 4 I cap plus 3 j cap. Okay, so now we have found r. Hijines na tip phalo le na he so hi tia choma je se ngai lo hi je point bo se na vet wa jong hi 4 I cap ta na ji the na he thei jing na. So when you become more familiar, okay, so you can simply directly say if the vector is going here I will have 3 j cap minus 4 I cap. Okay, directly. So the force will be force on 1 due to 2 is equals to so z into m1 into m2 divided by a mod r hi bha chila hi ajo mod iti ki hol katita. So root over minus 4 square plus 3 square. Okay, it's a coefficient pa hai na square na bol dio it's a coefficient pa hi square na bol dio. So how much will you have? So here I will have here 5. 4 square to 16 za 3 square to 9 za 9 plus 16 to 25 na root 25 to 5. Okay, so here how much is this by mod r the whole cube into r bar. So this is 6.67 into 10 power minus 11 into m1 hui pi ham. So 1 into 10 power 6 into m2 hu 2 into 10 power 5 divided by mod r who is at ham. So 5 cube. Okay, abana r bar he pi ha. So this is r bar. Equation number 1 ka ji pa hai. So this is your R bar. Okay, so minus 4 I cap plus 3 Z cap. Solve let's put them. So 10 power minus 11, 10 power 11 gets cancelled out. Remaining to PM. So 6.67 into 2 divided by 5, 125 into minus 4I plus 3Z. Okay. So you have to solve this. The cube. So, see, now this is the force. See, penny force force on 1 due to 2 is equals to 6.67. 2 7 are 14, 2 6 are 12, 13, 2 6 are 12, 13, divided by 125. Ama sa pena 2 into 4 I cap minus, okay, plus 3. So 13.34 into 3 divided by 125 Z cap. Abang lena x component of this force y component of the force ki dong thai chula na chi. So here this value na. So this is the x component of the resultant force. Okay. Abana hi chipa hi y component. Achum chuma hang ki do khare na chala y component x component he de mai cho. He chala vector pi split ball jing la cho na chepen bracket hong vil lang chi to in chi multiply ball vil lang abon le chun 3 to hin abon in multiply ball ki le chun na bracket hong le chun. Okay. And another thing is they can ask you the magnitude of this force. Okay. So how do you find the magnitude of this force? So here I will have 13.34 divided by 125 into chalaya hi chi chipa hi magnitude dik bolta chalai ka boldan paina bol dio. Okay. So root over, so minus 4 q square plus 3 square. So I will have here 13.34 by 125 into 5. So 5 into 25. So 13.34 divided by 25. So whatever value you have here is the actual magnitude of the force. Okay. So this one is important. Force pa na force on 1 due to 2 chipa dan pa to hin it's a magnitude pa dan pa in he thiamongai so chipen here. Okay, that is how you use the Newton's law of gravitation there. Exam also alang pia equilateral triangle to square ki pia chala chu question ki dong ji na. So the way to do is same, you find individual forces and then just add all of them, okay, using vector addition na. Question solve it in. Okay, so first question. So 3 equal masses of M each are placed at the corners of equilateral triangle of side A. Find the gravitational force on any one of the mass. So you have an equilateral triangle. I'll try to draw a perfect triangle. Okay. And you have how many? So 3 masses, equal masses na sila here. Butang hiti ang kipipa lahi namas sa penacho position I holo ngai chula na. It's mass position. Mass of si hilai la yamamti here do ngai cho position vector is ngai na. So therefore you put these things in a xy plane, okay? Center of mass I bol lai wa na. Center of mass holding azong chu xy plane like ko ya ba na chu position ki hol chula na. So therefore you do the same thing here. Put one of the mass at the origin. Okay. And then write the coordinate. Masapahi 0 0 ama kapahi side to PM side to A so na each side has A, so therefore you have A comma 0 khatpa khuza nam de ha equilateral triangle athilthum by ha dekati cho masapen to PM height, so the height will be root 3 into A by 2. Okay, the next thing is from the center to this, so this is A by root 3. Okay, the next thing is from the center to the perpendicular distance from midpoint. Okay, so pen hizan ha so pen hi A by 2 root 3 hi cho to min na mel chi ngai so equilateral triangle to chu so therefore this is A by 2 comma root 3 A by 2. Okay, ibola it's like A by 2 ha, so this is half na, this is A by 2. Okay, and the height is along the y it is root 3 A by 2. To position those na. So now we can find out the net force. So on any one of the mass at user, so mass hitting about 1 2 3 tute about 3 na net force holo na jala him. So if you look at this system, mass apena so 2 to 3 ki ka force from so So now you imagine yourself as 3. Now you will feel the pull force of attraction from 2. So let's say that is force on 3 due to 2. Okay. Again, you will feel force of attraction from 1 also. Na. Chipa chu force on 3 due to 1 due to. To chu chiten you will say force om chala na dang to lo pia. He chiten in the got value, so you'll get the net force. Okay. So can you write the two forces? So what is force on 3 due to 1? Z into M, M1 into M, na, M square. So divided by R cube. Mod R cube ito na formula so. It's like mod R kiti hipi ha. Kasi ba so distance chula na distance between the two masses. It's mod R kiti pa hi. M1 to M2 ki ka distance pa so. Oh, it's pening ka say na ito. So therefore here what is the value of mod R? So mod R is basically A, na A cube. Okay, M1 to M3 ki ka distance pa ko A chula na. Aba na vector chiti ki zede ha. So this force you see it is going in this direction. So this is your final vector, final position vector. This is your initial. So that means final minus initial na. So A by 2 minus A to piham. So minus A by 2 comma I cap. So root 3A by 2 minus 0 na. Root 3A by 2 minus 0 to root 3A by 2. So plus root 3A by 2 Z cap. So this is the first force. Force on 3 due to 1. Okay. R1 R2 chumchuma zilo hilana hita direct azi dan pahina neke thim chu ngai chu azi chu example la space jong lo time jong lo ja chu na hita a figure do do wa chilai kuna chu direct force ji dan pahina vector force ji dan pahina thim ngai chu. So similarly what is the force on 3 due to 2? So Z into M chi hija chu M into M to M square divided by distance between them is A, so A cube. Okay, so now the force is going like this. So that means final vector, initial vector. Okay, initial position vector. Na 0 minus AI cap, 0 minus 0 Z cap. So I will have here minus AI cap plus 0 Z cap. Na. Okay, so now what is the net force? Therefore, F net is equals to, so F on 3 due to 1 plus F on 3 due to 2. So how much will you have here? Let's add in the new page. So I will have F net is equals to, so force on 3 due to 1 plus force on 3 due to 2. So which is, so Z into M square divided by A cube minus A by 2 I cap plus root 3A by 2 Z cap. Okay, plus Z into M square divided by A cube minus A I cap. So here I have Z M square by A cube common na. Okay, let's do it like this first. So here I have minus A by 2 I cap. I to I has no. So minus A I cap plus root 3A by 2 Z cap. Abanan sila jong evaluation A dim set na tam do siya AM. So A jong common do kilauchun. So ZM square divided by A cube into A. So I will have here minus I by 2 minus I plus root 3 into root 3 by 2 into Z. So A hat to A cancel out. I have square. So ZM square divided by A square into is that here minus 3 by 2 I, okay, plus root 3 by 2 Z. So therefore F net is equals to what? So ZM square root 3 is common na. So root 3 into ZM square divided by 2A square. So minus root 3I plus 1 plus 1Z. Okay, so actually this is your final force. Na force part so ala to hi kasi ba so magnitude jang kitong thai chuna la hi magnitude tin hold on ha. So what is mode of net force? So root 3 into ZM square divided by 2 into A square root over root 3 square so piha 3 na plus 1 square to 1. Okay, so how much will you have? So root 3 into ZM square divided by 2A square into, so root 4 to 2 na 2 cancel out. So finally, so root 3 into ZM square divided by A square. Chipahi answer that's what. See another method of doing this one na. Apol na ko chupiham tele hichi force pa to hinchi force pa na. vector addition formula ko a square plus b square plus 2ab equals theta pa ko naman dito sila here. But the problem is you need to know what is this force, the magnitude of this one. Okay, the magnitude of this one, and then when you apply that big formula, sometimes inside the root here you may have problems here there. Okay. So here I have same mass. So logically, if you see this force and this force will have the same magnitude. Okay, but sometimes you will have different masses. Mass ang kibang law din na. Triangular parallelogram formula pa naman sometimes the calculation becomes very complicated. Okay. So vector pa pati na digest the best method is I think is to use this one. Okay. Okay, next. 3 equal masses or M each are placed equilateral triangle bamana side A. Find the force exerted by this system on another particle mass M placed at the center. Iti ay triangle kaluma. Question kibang na so question kibang din same mass M om na sila mass M thum tam so side to A hiza. Ale hesi solve natin nga choma sa pena JEE bolota. So hesi xy axis ako ngay na jitu position here ngay so mass si aso na. So I will put it again in xy plane. So this is x, this is y. Masapahi 0, 0 amding. Panapahi a, 0 amding. Nakatpahi a by 2, root 3a divided by 2. Okay. To hi mass khat pai hoy ki koyam mass placed at the center of the triangle na chila hi mass khat ki koi cho center ai. So same mass M is placed here. Okay, mass M. Ati lechin center pa hi position hi pi dia. So position to x pa hi ki bang na. See, this is x. Okay. So along the x it is still a by 2. I have along the y to zat dia. Along the y to chipen hi na. So this one I told you to remember is that dia chipen here. A by 2 root 3. Okay, distance from the centroid center to midpoint of the side to A by 2 root 3. Alias, so therefore you have A by 2, A by 2 root 3. Okay, to chu hichi alayam pa he na net force hold use. Okay, so let's say mass 1, 2, 3 got you. Mass pa he mass 1 to 10 original pa he khat pa 2 khat pa 3 malalayam pa he 4 to 10. Atile hin chela he 1 to 4 ki kazong hi force of attraction um chuna chela he. So between 1 and 4 you will have force of attraction. So force on 4 due to 1 and 4 pa ya kai chuna malanga. So therefore you have force on 4 due to 1. Okay, along the one side na. So force on 4 due to 3. Okay, and then force on 4 due to 2. Logically, if you try to assume, guess it, okay. Chibetang mass of sikibang chuna na mass of sikibang and then abana chu alaya pa jong hi mass m so ale to hi 1 to 4 ki ka force pa hi gmm by r square na example chu distance by r hi la chun gmm by r square hong hiding chuto banga chu 4 to 2 ki ka jong hi na gmm by r square chuto banga chu 3 to 4 ki ka jong hi gmm by r square hotel chun force of sikibang chuna. See, think of this. If I have one force along the side 10 newton, along the side 10 newton, and along the side 10 newton. Ama hoki ka angle hi 120 na bona hi 120 to 120. Atila chun alaya hi na alai ta hi block khat umal chana block chu hoilanga chi de. A chang dem. Chang lo dis na ji chu lai equilibrium am cho block pa hi. So simit force hoi kitu chana kai wala chun alaya block um pa hi chang lo so lai. So here the net force is 0. Okay, actually. Even logically thinking also you can guess it. Here the net force will be 0. Okay. As a technique parts of mangutin proof hotina net force 0 as a hum ti holiday. Okay, so first I have to write force on 4 due to 1. Is that the hachu? So z into m to m square divided by to hi 1 to 4 kachi pa hi sa ta. So a by root 3 na. Equilateral triangle at home melsi dikati cho height pa root 3 a by 2 is a he chilai para he chilai pa hi chi hi a by root 3 hi za bana chu chilai para chilai hi a by 2 root 3. Okay, so remember hati le chilai hi by a by root 3 the whole cube. Okay, into is that data to a force pa hi velocity force on 4 due to 1 chi pa hai na force pa hi tilanga chi chula na, so therefore this is your final vector and this is your initial vector. Okay, so final minus initial ball ki diu na chala hi, so therefore I have 0 minus a by 2 chu minus a by 2 I cap plus 0 minus a by root 2 a by 2 root 3 chu minus a by 2 root 3 z cap. Okay, so how much will you have here? So this is 3 root 3 na root 3 cube pa 3 root 3 is so zm square divided by a cube bana bracket apart ako a hing polar ro lechon, so a 2 jong common na a by 2 da ro lechon minus I minus 1 by root 3 z. Okay, so a gets cancelled out, so you have 3 root 3 zm square divided by a square, not 2a square, so minus I minus 1 by root 3 into z. The first force na between 1 and 4. Okay, similarly you have force on 4 due to 2, which is only solve lechon 4 to 2 ki ga force pa ko na, so how much will you have? So zm square divided by a by root 3 the whole cube into final minus initial. Hiti hi force chi lechon chi final vector chi initial vector na, a minus a by 2 chu a by 2. Okay, so I will have here a by 2 I cap bala 0 minus 2 a by minus 2 root 3 z cap. Okay, chizong solve ke lechon, so you will have 3 root 3 into zm square divided by bracket apara ho 2 na do wala chun 2 hung po do ke ding na ezong na do ke wala chun a to a by a cube pa ke cancel ala chun, so finally you have here again I minus 1 by root 3 into z. Okay, equation number 1 to equation number 2 tiuta abana hi between 1 and 3 4 and 3. Okay, so force on 4 due to 3, so zm square divided by is that the see, so zm square divided by a by root 3. Okay, the whole cube to 4 apala a na chi wala chun he chi pa final he chi pa initial na, so a by 2 minus a by 2 to 0. Okay, so root 3 a by 2 minus a by root 2 root 3 to that the so see I'll do here root 3 by 2 a minus a by 2 root 3. Okay, LCM to 2 root 3 yung hitting, so multiply by root 3, so I will have here so 3a minus a. Okay, so here I will have 2a divided by 2 root 3, so 2 cancel out, a by root 3 yung po na sila a by root 3. So here I will have is that sila here, so root 3 by 2 minus a by 2 root 3 2, so here this is a by root 3. Okay, so you will have a by root 3 z cap na so I cap pa 0 na. So this is how much 3 root 3 into zm square divided by a square by root 3. Root 3 is a cancel calculation. You have how much z cap. Okay, it is involved it in quite lang na, so 1 by root 3 is 0. Okay, without cancelling. Okay, now let's find out net force. So what is the net force? So the sum of all those one. Okay, force on 4 due to 1 plus force on 4 due to 2 plus force on 4 due to 3. Okay, also how is so boning gom from lechon na masa paso piham, so 3 root 3 zm squared by 2a square 3 root 3 zm squared by 2a square chilai piha minus I plus 1 by root 3 z. Okay, plus abana pa 3 root 3 zm square divided by 2a square chilai pa I plus 1 by root 3 into z di na ham minus zo he chipa jang hi minus, and the last one is how much, so 3 root 3 into zm square divided by a square. So 1 by root 3 into z. To hinna I to I ho z khom velang z zo si z khom la chun, you'll get the answer. Okay. Common he piha 3 root 3 zm square by a square he common so na bona he. So here I can do one thing. Last term pa hai na, so divide by 2 multiply by 2. Okay. Aji chu chalai term pa hai che pa common chu na, so you have this term in every equation. Okay. Tun hi che term pa ye polang si do le chun 3 root 3 into zm square divided by 2a square. Okay, remaining is what? Minus I minus 1 by root 3z. Okay, plus I minus 1 by root 3z. So plus 2 by root 3 into z. Okay. So you solve this. It's minus I to plus I ki cancel that. Okay. So it's 3 root 3 zm square divided by 2a square. Na. So this and this. So minus I plus I cancel out. Chito hinchi piyong po diha. So 1 by root 3 plus, minus 1 by root 3 minus 1 by root 3, so minus 2 by root 3. Okay. And then you have here plus 1 by root 3. Plus 2 by root 3. Na? So this 2 also gets cancelled out. Finally, you have, what is the answer? 0. Okay. 0 into anything is 0. Na? Hechala bracket sunga pa hai 0 ong here. 0 into this is 0. Okay. So finally, the net force is 0. Okay, let's solve one more. I think this is the last. Okay. 4 particles. Triangle eyeball zato is square. Na 4 particles are placed mass to ppm. So m, 2m, 3m to 4m gp na. So find the gravitational force acting on the mass 2m. 2m net force hold it in that. Okay. So you have a square. Mass to ppm, mass to m. So mass 2m, mass 3m to mass 4m. Okay. So square is just side to a na bona side a. Then put them in the xy plane. Okay. So x and y. Coordinates is that the 4m pa hi 0, 0 amding. 3m pa hi a, 0 amding. 2m pa ho a, a amding. Abana chu m pa ho 0, m. 0, a. Square hi halo pichulan na. Ipipin he do ha square hi. Aside to a hi lechon diagonal is that the diagonal he. Root 2 times of a na. Diagonal so. Half of diagonal so root 2 times of a divided by 2. That means a by root 2. Chichon na melsi dewa square na. To hi ho hin question chun 2m hi net force holder na. So that means we have to find out here. Okay. So here see between m and 2m there is force of attraction. So this is force on 2 due to 1. Okay. Force on 2m due to m. Abana chita banga chu between 1 and 2, 3, 4 and 2. So force on 2 due to 4. Okay. And then you have force on 4 due to 3. Hichi ho he thum hina hi cho thumi force hoina ji wa banana plus or like sizing bolan cho. Masapena force on 2 due to 1 zat ham. So z into m into 2m to he mass ke bang talo na m to 2m. So divided by distance ko zat ha m to m ki ka distance ko side of the square chu a hi chola na chipen a cube abana chu hiti la na chi wa la chon hiti la force chi la chon chipen hi final chipen hi initial na final minus initial. So 0 minus a to minus a I cap, a minus a to 0. Okay. So how much is this? 2 into zm square divided by a square minus I cap. Okay. A hat to a cube cancel. Abana similarly force on 2 due to 4. Is that the here? So z into 2m into 4m divided by 2m to 4m because distance pa hai zat ha diagonal chulana Japan here. So this is root 2 into a. Chichu root 2 into a the whole cube. Okay. Abana vector pa hai below chulanga chulana. So final and initial. 0 minus a to minus a I cap minus a z cap. So this is for 2 or 8 zm square by 2 root 2 a cube. A common nakala dollar minus I minus z. Okay. So here this is how much? 2 4 are 8. 4 zm square divided by root 2a cube. Chilaya 4 by root 2 is that. So 4 by root 2 means 2 root 2. Okay. Cancel bola jonong pot beta. Is that chilaya. So minus I. A to a cancel a square minus I minus z. Okay. Equation number 2 tiuda. Masapasu equation 1. Chito bang also force between 2 and 3 na. So force on 2 due to 3. Chito z into 2m into 3m divided by 2 to 3 ki distance pa hi a chola na. So therefore you have a cube banachu equation pa force pa chalanga chila chun chi final chipen initial. So final minus initial to a minus a to 0, 0 minus a to minus a z cap. So how much is this? 2 are 6 zm square divided by a square minus z. Okay, question 3. To hi chio thomena go vala chu na chu answer jing da. Okay, so therefore what is the net force? Net force is force on 2 due to 1 plus force on 2 due to 3 plus force on 2 due to 4. Okay. Amasa pa piham 2 zm square by a square minus I cap. Okay. Plus anina pa 2 root 2 zm square by a square. 2 root 2 zm square by a square minus I minus z. Okay. Abana thumna pa 2 6 zm square divided by a square minus z. Okay. To hi next step pa hai na I ho zo si na khop khom deu z ho zo si na khop khom deu apala common am zong lo yo chana chala hi. So common is what? So its term can be divisible by 2 na. So 2 into zm square by a square is common la dong yo chala hi. So 2 into zm square by a square is common. Then the remaining is what? Minus I root 2 minus root 2i minus root 2z and then minus 3z. Okay, so this is remaining 2 3 or 6. To he chalai ko na so in soft leo chun na se 2 into so zm square by a square I to I khoda khom leo chun bi ha. So minus I minus 1 plus minus 1 minus root 2 I. Okay. Abana chu plus ga hom khen gate I to z khona. So you will have here 2 zm square divided by a square. I will have z part who minus root 2 minus 3z. Okay. So this is the net force. Ite ka zinan so ji component pa hai na chipen hi x component he za I ke pa hi chipen hi y component. Okay, y component or x component. To exam form vela ki do khala chun na chalai value pai tham anop deu nan pi me theu jana chalai hi. So otherwise this is how you solve it. Okay. To chu magnitude holding ala chun square plus j square na under root na bol deu chalai hi. Okay, hi chan hi bol tau den na loss of force question hoi za. To chu abana khu electric field e bol deu to electric field jong khu tang hi chi la ya force e bol pa hoina. Exam ko lang pi a force sang I feel as I question ki ha do cho electric field a hona electric field jong chu ta bang chara ki cho okay, we have to write it like this. It's very similar to this vector ke bandan jong bona ki bang so ke na is a force by net hem version field question hona solve the cho alang pi a chu in general force a question ke dong be se lo na he bang chu net force sang chu net field jo ke dong thei cho jela hem. Okay, so I hope you understand Kepler's law to Newton universal law of gravitation na Newton's law of gravitation chu it's an jana. Okay, then we'll do this much and next time we'll do electric gravitational field potential energy kiti ho na potential kiti ho pa nai bol du chu. Okay, so thank you for watching.